Good morning, good afternoon, good evening, wherever you are and joining our third session of the second webinar. My name is Uwe Rüdenklau from Infineon, and a warm welcome here to the 5G-ACIA webinar series. And I will introduce you a little bit at the beginning before we go into the details. I'm speaking here live from Munich, so don't feel alone, even if you don't see here the others. At the end, we get more interactive. Yeah, please welcome the two speakers you see already. So Josef Eichinger from Huawei, live also from Germany, Munich, and Bernd Kerche, who's from Festo, in this case live from Stuttgart. So we're all live, so it's not a webinar which is coming from the tape. So the two gentlemen, as I said, talking about using digital twins for 5G in production. And here, these digital twins will be one of the key enablers for the flexible factories and the new supply chain. And you will learn more about this and what is all behind the technical side. These features called Industry 4.0 concepts, interoperability areas, different vendors, communication network, the backbone of this. So please listen to them, and a warm welcome now to the two speakers. Thank you very much.
Now I'm so keen to jump in with the first part, and perhaps we have a look at our agenda. After this introduction, I will try to explain why is interoperability so important for us, and afterwards Josef will tell about the AAS concepts in relation to digital twin, especially focused on 5G, and we will end up with some use case examples afterwards, and of course with some summary outlook, and you will also have the chance to come in with your questions, and we will try to answer them what you brought in during the Q&A chat channel. Why is this interoperability so important for us, for OT companies? OT means operational technology, and as one example, you see a vision statement or a strategic roadmap from the platform Industry 4.0. That's a more European centered initiative hosted by the German government, but you can also see comparable slides from activities in the US coordinated by the IIC, by the Industrial Industry Consortia, for example. And we will come down from this political attitude and look one level below. What is from the technical side important to achieve such interoperability? And then you see, of course, some legal aspects that we do not want to discuss today, and also some technical questions. How do we build up edge systems or something like that? What we want to have a closer look is what is relevant for standardization and how to achieve this integration capabilities. And we have two main technology working areas: the reference model architecture for Industry 4.0, which is standardized on an IEC standard 63088, and also this administration shell concept that we discuss in a wider range as an example for a digital twin concept. And we will see afterwards how this could be done in relation to a 5G network. And our headline is digital twins. And an important thing is that it is, if you look at 5 projects discussing digital twin perspectives, you could have the luck that you get 5 different definitions. The important thing is to make these concepts converge, and therefore it is important to bring these concepts also to standardization. This is the key element to enable this interoperability. And as I mentioned already, there is a reference architecture model out called RAMI 4.0 that was part also of this discussion in a work item that was coordinated by Josef Eichinger, which ended up in a white paper that you can also download, and you saw it with the invitation. And the other thing is the concept of a digital twin representing a digital description of all assets involved in a production plan. And this is called an administration shell, and we will see in the next steps how we can use this concept and how it is relevant for our aspect. But before we do this, now you participants are invited to join the first poll, and we would like to know from which area you are coming. Are you more from the ICT side, or this 5G vendors, or other IT vendors, or are you more a machine builder or plant operator or somebody dealing with automation technology and others? This will give us a very beneficial information where you are coming from and how our audience is organized. And we will give you a minute to respond, and we are quite excited about the results. Until we see something, we could discuss the results from the first poll, and we have a almost clear majority from ICT participants. At the moment, I see 49% of our participants are from ICT side, 24% from OT side, and 14% from academia, and 7% others.
Okay, good. I hope my screen is
now. We see a
visible.
presentation. Yeah.
And sorry for this technical issue, but it's always the case if we have many screens. But now we managed it because we don't have an AAS description of all of our equipment here, and that is actually the drawback. And if we now go to the 5G time, and if you see Industry 4.0 has worked on digital twin for a long time now, and also how to define AAS, it's in the standardization phase. And we, many of us, we know the demonstration, what was shown in different exhibitions like Hannover Fair regarding asset administration shells and Industry 4.0. And now if we look to the future of smart factories or process automation, we see that we will have 5G as a kind of basic element of the infrastructure in future. So it means 5G in a factory will become a backbone of the communication infrastructure and an essential part of the entire assets what you have, not just from the physical point of view like devices, base stations, and so on, also from the functional point of view and from different other aspects. And the idea of this work item, as we started with 5G-ACIA, was how can we bring this together? So industrial 4.0 concept of asset administration shell and the 5G system, and what do we need to do in order to integrate both in a meaningful way for your benefit. At the end, we made a white paper, and you can download it, as Bernd has already mentioned this, and we have also discussed here how can we structure this. And actually, what is necessary to describe? If you are familiar with asset administration shell, you know the asset administration shell consists of different submodules, and it also covers different perspectives of the entire, let's say, factory setup. It's not just what I said, not just the devices, the engines, sensors, and some pumps or whatever drives. It also contains virtual parts. If you look to this slide here, I will just add a pointer here. Also contract aspects, also data sheets, also how to handle the life cycle of a certain product. And now 5G come into the game. And how to do this in future? We have to find a way to describe the 5G system to cover all of these aspects here. And this is for today. And in future, we saw that in the definition of asset administration shell, there's also a trend to integrate more intelligent into the asset administration shell, as here shown on the picture on the right side. So that means there's a clear way forward that asset administration shell elements can still communicate with each other in order to negotiate a kind of best performance trade-off. So that means here's this active administration shell will support, or it's also sometimes called interactive, will support self-organized factories, self-organized machine parks, and at the end also this kind of self-organized factory as a service concept. And with this regard, we have to think about what is now, how to structure the 5G components here. And if you know maybe a bit about 5G, 5G is not so easy like Wi-Fi. It's a bit more complicated, but this has a reason, because it supports also extreme high quality and high flexibility and different services. But nobody wants to know all of the details, what you see on the right side, all of the functions inside. What you want to know is actually how does it work, and what is the meaning of this 5G black box, and finally how to connect your machinery, your sensors, your network. What is attached here? If you look to the laser pointer here, what is attached to your 5G UE, and it could be a fully independent, not independent, but a full-blown subnetwork, maybe with TSN domains. On the other side, you have also the power of 5G to set up different links with different properties. We call it here PDU sessions or quality of service flows. But actually, you as a user of this, you don't want to know the details here. You just want to know how to set up this link, how to characterize the properties, and how to get the quality of service what you would like to have. Also endpoint, start point, and properties of this. But on top of this, you also want to know, is the promised quality, the quality of service definition, also guaranteed in the network? And not just how to manage it, but also how to monitor it, how to get a continuous update of the performance data, and how to take this data into your control system. 5G supports also a kind of, let's say, flexibility in this regard, that you can deploy certain functions in different places. It's not just to set up a link, it's also how the link can be organized, maybe maybe the buzzword slicing, how the link can be organized in order to connect different layers of a factory, different domains of a factory, how to isolate this. And all of these nice properties needs to be described in a 5G-AAS solution at the end, in a definition, a submodeling of 5G. And if you look here to the picture here, 5G enables different slices. That means each UE can have up to 8 slices. Here in the picture, we have only 2. And each of the slices can have an endpoint in different areas of your factory. It could have an endpoint in a different domain of your factory, in even in a different security zone, because each of the slices are really isolated like VLAN or VPN. But this makes the system a bit more complicated, but at the end, this is exactly what you want to have with regard to flexibility. And now coming back to how to describe it. So after a long discussion in 5G-ACIA with all of the members, or with many of the members, we decided to distinguish between a 5G network AAS submodel and a 5G UE submodel. The reason is because the network is a kind of infrastructure element, while the UE is more flexible, and also maybe you have a big mix of different type of 5G UE or 5G capable devices from different suppliers, from different sources, and this maybe needs a bit more flexibility, and therefore we decided to keep it independent from each other. At the end, it must work together for sure. So it means what we said is what we defined here in our white paper, and also in a proposal what we have sent already to the ISE standardization community in charge for the standardization of the AAS and digital twin part is we structure the submodel of the 5G AAS. Please keep in mind, we want to describe the 5G system as a black box, not each element, just as a black box. But what we need is to describe the 5G system in a kind of physical manner. That means where are the boxes, which boxes do you use, what is the license model behind, what is also maybe the SLA model, what you have agreed with the supplier of the network, with the vendor and operator of the network. Also simple things like hotlines and contact information if you need some support. There's also a section about the physical topology. Topology means here, where do you have deployed in your factory or your logistics supermarket the antennas? Because you want to know if something goes wrong, where is the antenna located? Where is the base station located? What is about the cabling? And all of these different things you want to know. And also, where are the different functions? Please remember, before we had a simple display about this kind of magic UPF, user plane function. This is a logical function, can deploy it on different nodes in your edge computing IT infrastructure. But where is it deployed? You have to have a clear knowledge about this, and this is also a meaning of this physical and logical topology. But the logical topology is more about the connectivity, the links. We saw in the picture before this PDU session and quality of service flows. Which link from a UE, 5G capable UE goes to which destination? Or which UE is connected to another UE? This is reported in this in the logical topology here. That means we have here two different types of descriptions, a logical network, but more specific, it's also the 5G PDU session list. It's a kind of list. And your network automation system could read this list and could set up, together with the 5G network management system, so all of these links in a very automatic way. That means somehow you see what you want, and then you start it, and then it runs as you wish it, and as you have defined here in the list. Okay, now you have it defined, but what's happened if you have it defined and it runs in the daily work, and most of the time, 99.999% of the cases, without any errors, but sometimes you get an error. That means you want to know exactly what is the performance of each of the links, what is the performance of each of the nodes in a timely way, not just every day once, maybe every 10 milliseconds, every minute. It depends a bit how precise you want to have it. And therefore, we have a section about the network performance information and event subscription. This section is updated by the 5G system in order regularly, in order to give you as a user of the network a clear understanding about the current KPIs, latencies, network loads, number of connected users for each of the different links. But this information is still part of the submodeling, but different sources are in charge to change it and to update it. There's, from the planning point of view, your network planning, your deployment planning has to update at first this AAS. Then the integrator, and maybe if you take an MNO to set up the networks, and also the MNO must update this information according to the settings what he has chosen together with you. The component vendor must help to specify all of the components used and all of the links and the properties. And also, last but not least, the 5G network exposure function, and also the operation and maintenance functions of the 5G network. And it's actually the operating system of the 5G network. Coming back to the active AAS, because at the moment we discussed only the passive part here in the picture on the left side. Since the active AAS, you can still have some additional algorithm scripts in order to manage the network a bit more smart based on the information what you have in your asset administration shell submodel with 5G in mind. Okay, now let's go a bit more to the top level view. Now we have described the 5G network AAS. You see it here in the middle as a kind of picture here. We have also described in a very similar way the 5G UE, also as a kind of submodel where we have a physical notation, where we have the logical link configuration inside. Also some other information are stored in the UE, but maybe not stored in the UE, but stored in the AAS. And the AAS, you know it better than me, could be hosted in a secure place somewhere in your factory. But then we need to have interfaces. And this picture here described how to add the information to the different AAS submodels, network AAS and UE AAS. It's a 5G system, but it could also be your factory system, and all of them has to have access to this data. And finally, at the end of the day, your protocols, for the engineering, maybe the automation ML, for the operation OPC or something else can take this information in order to optimize the daily working. Yeah, that was somehow an explanation and an overview how the 5G AAS would look like, 5G UE and 5G network AAS. Later on after the session, maybe I'm happy to discuss this with you and whether you have some interesting suggestions on this. But before we go to the next session, as you know, we're always interested to get your feedback here. I would like to ask you a few questions here. First one is, how important do you consider digital twin for the factory of the future? Extremely important, somewhat important, neutral, not very important, not important at all. And there's a window popping up now, and please take your mouse and whatever you have, maybe your finger, tip on the A, B, C, D, and E and give us the feedback. Have a short reflection on the results, and you see, I'm happy to see it actually.
Quite interesting, yeah.
I was not sure whether we get this interesting answer here. You see that digital twin is very, very important for you. I just summarize A and B here, and that means more than 86% of the participants here sees a very strong need for the digital twin. That's perfect. And now let's go
to a lot of digital twin enthusiasts.
Yes, maybe yes, it's good. And now let's go one level deeper and ask whether you want to have 5G also as a part of the digital twin, as part of the AAS description, or whether you say it doesn't matter or even you don't care. This is actually a very interesting question from my side, and I'm happy to have this opportunity to ask you. It's very good to see that you still see it as important, maybe not vital important. That means you can still live this out. But important means for me, that is at least my personal feedback, and maybe Bernd can also, as an expert in AAS, give his feedback. But for me, as a 5G guy, it's actually a very important statement that you need to have somehow this kind of AAS modeling for the 5G system. What is your impression, Bernd?
Yeah, this gives a good support that it's worth to continue work on this topic and bring it to life.
Yeah, that means it's also good for us, because as I said, we have already started to share this report and this information with the standardization group in ISE, and this feedback now give us also a momentum to say, okay, guys, please continue. This is important for all of us. Yeah. Okay, thanks a lot for this. Now we can continue with the next slide, and I guess this is about you, Bernd.
Yeah, I'm already about to share and to give this what we have done now in a more theoretical way and bringing up definitions. I think it's good, especially from the OT side, to have a example that brings up the major points and gives perhaps a better understanding how the production network could interact via a digital twin with a 5G network. And we have selected one example that Josef already started to discuss. One of the main aspects when using a 5G network in a production environment is how is the quality of service translated in OT language, how is latency, how is availability, how reliable is this network. And you see in purple on the left-hand side a very, very simplified model of a production line with various assembly stations, and each one is equipped with a UE in ICT language or a communication module in OT language, and the information is exchanged via, in this case, a very simplified 5G network. On the top level, you see the control plane and the user plane, and this is connected. This network exposure function I would call like an API that opens the relevant parameters to the user. In this case, the what we call in OT language a PLC or a programmable logical controller, for example. This could also be a control function implemented on an edge, but this is not relevant in this case. I think the really operational data are exchanged via the user plane and the data network. That's the process data, and the organization is done from the application function in interaction with the network exposure function, and the more details that as Josef described is hidden from the application, and this gives the chance to interact with the network and control the relevant parameters that are extracted. And this is what was in this work item that produced this white paper. This was quite interesting to watch, that it wasn't so easy to extract the 15 most relevant parameters for describing a 5G network. It would have been easier to say what are the most relevant 100 parameters, but then maybe the use would be a little bit limited. And when we do a little exercise in a description that is relevant for the platform industry 4.0, you see the administration shells on the left-hand side describing the 5G system, and on the right-hand side you see the factory control or the PLC, and how could they interact with each other. You could the production controller requires a certain quality of service to fulfill his time and quality requirements within his production line, and this is kind of making a deal with them, both because the 5G network has to evaluate or validate, are these quality of service requirements feasible anyhow, and is it possible to adjust the relevant parameters for the production network. This could also, the result could also be that this is not possible. Then the production system has to modify his requirements. So this could be, this deal making could go on, and in the best case or in an optimal case, the reserve unit informs the PLC what you want to do is what you want to implement in the system is feasible. The parameters are adjusted. You can start your production flow and can rely that this quality of service that you require is guaranteed with the necessary reliability and latency, whatever is needed. This is a relatively simplified example, but I think that this could make visible on the one side how an application interface for a 5G network could look like, and on the other side how this interaction and this dealing with the administration shell or the digital twin could go on. And now we are already touching our next poll. How important is that a 5G network or 5U vendor provides AAS compliant data models and interfaces? That is now for the vendors in this audience or participants in the 5G-ACIA could get a feedback how important these features are needed. Please don't hesitate and bring up your answers. It's comparable to the last question. The features are not estimated as vital, but even is quite important with 63%, and only 12% say that it is not necessary and 2% don't care. So it's a clear majority supporting this approach. Would you interpret it, Joseph?
I see it as a kind of request to us as a vendor. I have to go back to my product management team now and say, okay, the majority of this participants want to have it. And that's a very good and a very helpful input, yes.
A nice feature to add without additional cost.
We will see, yeah. And as I think your example has clearly shown that this neutral, well-defined interface gives you the opportunity to connect all of the machines together and to establish a kind of independent language or independent communication method without taking care about from which vendor is coming what.
And this is also one of the upcoming new work items in the 5G-ACIA that gives a closer discussion about the features of this network exposure the interface. So this discussion will continue and bring it more detailed.
Yeah. Then I guess I can now share.
I share the second question, perhaps. Yes. This is a more general question to get a feedback where our participants are coming from.
Still some minorities from Europe.
Yeah.
We have also, it's from Asia, so it means quite late in the night. I hope it's not too late. Let's see. Okay, thanks a lot. So the outlook and the summary. Yes, outlook and the summary, and what we discussed right now was we have introduced a reference architecture model, and we have also discussed how the 5G network AAS and UAS can be structured. Some logical communication interface, we gave a proposal. Now it's also a matter of maybe standardization, and actually I guess here we have to connect two standardization groups. One is the IEC and another one is 3GPP, to have both in a very aligned way. We gave some use case examples, and what I also would like to share is that we have also a unified method for engineering and deployment and monitoring and control of 5G network if everything is described in this 5G network AAS submodels. 5G-ACIA has proposed which information and data has to be exchanged in the white paper on the 5G exposure interface. That means here I want to make clear, and this is described in the picture on the right side. It's a 5G and AAS and digital twin work. What we did was describing how we can describe information in a standardized way following the asset administration shell concepts. But which information should be added to the different sections, what we discussed before? This is defined in the work item about the 5G exposure interface. And we have here already also a white paper, and you can also have a closer look to it, because it's not only about data, it's also about control mechanism, which capabilities this interface should enable and give, and which kind of information should be somehow posted in the 5G AAS submodeling in order to give all of your machineries from OPC-UA to the TSN time controller access to the 5G data as a monitoring data, but also to the control information. The standardization at Platform Industry 4.0 and IEC TC65 Working Group 24 in charge for the definition of the AAS submodels has been started, and we have already exchanged this information with this team, and we got also a reply. It needs still more work, because this was a very starting point. Now, on the one side, we have the continuous development of the AAS concept in direction of active AAS, interactive AAS. On the other side, 5G is also developing. Now we have release 16 coming soon. Release 17 is in the process of the standardization, and we have also, as 5G-ACIA, contributed to the definition of the release 18 coming maybe in a few years to the market. It means what we have now described in this AAS is a good starting point, but we need still to continue here and to update it along the way of 5G, industrial 5G. That's all from my side. Thank you very much.
So far,
perhaps a personal remark also at this point. I think the benefit of this work item was not only to bring up this white paper. I think it was the better understanding from each other, so that the Industry 4.0 guys have a better understanding how to interact with the 5G network, and the other way around also, where are the demands and how is this digital twin philosophy. And I think this is really a benefit for all of us coming out of such interaction. I think that's a strength from the 5G-ACIA in general to improve this common understanding of those groups.
Thank you, Bernd. Yeah, this shows also, I would say, how you presented it from both ways or both directions, from the ICT OT, so the user also. As Bernd is from Festo and Josef from Huawei. So far, I have not seen a question in the Q&A window. So I'm wondering, hopefully it works in general, but as said, you can ask for sure also your questions still now. It's possible. If not, I would start maybe with a question first to Josef, maybe to warm up there. Josef, you explained that there will be now also follow-up discussion with IEC working group to standardize this a little bit more. Do you have any idea how long this could take as we just start to initiate it?
Actually, I have not so much experience with IEC because I'm a radio guy. I have more experience with 3GPP, but I expect that needs a bit time because IEC is a huge organization and it's on a European level. So that means all of the different countries and different stakeholders have to agree on it. But there's already a lot of work has been done already before. So that means they don't start from nothing. And I know that leader of these work groups are extremely familiar with AAS concept, and now after our work they also have a bit more information about 5G, and so I think it could come at the right time if release maybe 16 or 17 is in the market. Let's say 17.
Okay, I see.
It's my expectation if I look to the standardization.
But IEC, the workflow itself is not too fast as I experienced it. A year is not sufficient to bring a work item to IEC. It takes it's relatively easy to need 2 years or so for, because of there has to be established a certain draft, and the feedback is taken from all the IEC, and it is not really a fast process.
That's the reason why I said release 17, because each release has somehow 15 to 18 months. Now we get it soon, release 16 on the market. So it means in 18 months, maybe 2 years, it could happen, yes, hopefully.
Okay, thank you. Yeah, so also, let's say from a different angle, as I'm from the semiconductor side, I know it there from IEC where I participate in the semiconductor, you can say it's usually 2 to 3 years there even before a standard is published then finally. But for sure, there's interim work and interim decisions on a global level. Okay, just looking, I still don't see their question. Maybe then a second question also to Bernd is, you showed this one example with quality of service as an example where to use 5G and the interaction. Is this from current view the most relevant one, or you showed it because it was let's say in a certain way easy to explain? Or is there
no, I think that's from application side. I think the most relevant, if you think about a real production plant or assembly line or something like that, then I think this are the first parameters that have to be adjusted and defined. And a 5G network, as I learned, is not a wish concert. You cannot organize it that you get for every UE 1 millisecond with 900 megabits per second in download or something like that, you have to adjust it for the requirements of the individual components. I think this is when setting up a 5G network in a real plant, these are the first tasks that you have to do when you commission the equipment and get it into running.
I see.
Maybe
Okay.
complemented to this in the white paper, but also in the internal report, because you should not forget we have also an internal report in 5G-ACIA for the members, so please join. But in this we have also different use cases analyzed with a completely different scope. And but as Bernd said, this quality of service setup is an essential part. At the very beginning, otherwise nothing works. Yeah.
And then one of the next steps might be then the quality of service monitoring when the plant is running. That's what is most interesting if you are looking for errors or something like that.
I see. Yeah. Thank you very much. So I still don't see their question. I said hopefully it works. At least last times in the session it's always worked. So again, please feel free to write down any question there. From the maybe giving a few more minutes. From also from the polls, we saw that as you summarized already, that 5G as well as digital twins itself was it's been extremely and somewhat important or vital even to integrate this. Also the 5G feature there. So maybe a question to Joseph, do you think, you said this needs to be still discussed for sure within the industry. So this is something which is at the very beginning, also because we are missing, as we discussed, standardization, or are there already any, let's say, examples which can be shown? We have also this other working group, which showed this working group 5, how it's called, where we show examples. This is something we can demonstrate there in the future also from 5G-ACIA.
As let's say, at the time being, this in ICT community, and that was exactly also the advantage what Bernd mentioned of 5G-ACIA is that we come together, we share information and thoughts. And from the ICT point of view, this administration shell concept was fully unknown. And it was something what happens in industrial environments, but doesn't mean anything for wireless communication. But now in this common work, we understood that 5G cannot be isolated, deployed. It is part of the factory production system. And we saw this in the feedback in the polls that this is also the opinion of most of the participants here. And now we have to go the next step. We have to convince also us as a vendor and also the standardization to take care a bit more about this specific needs. Each of the vendor has for sure as a mechanism to monitor and to set up the system, but it's not very much transparent to the factory network management system. And that is, I guess, the biggest step what we have to take forward here. And that is always, we need to work on this. Otherwise, it will not happen just because it's Christmas. We need to do something. Yeah. But I see also there's a question in the
Gustavo has raised the question. Perhaps we should repeat it for all.
Yeah, I can. For whatever reason, I can't see it at the moment.
What he's asking, considering the modeling of a 5G network AAS, what are the most relevant parts to be modeled in the 5G network? Maybe it's not necessary to model all of the functions in the core network. Exactly. Maybe I want to take this question. That was the idea of the black box thinking. That means what we don't want to do, we don't want to share, not we want to share for sure, but it's not necessary to share what you said clearly, all of the details of a 5G architecture and functions and control mechanisms. It should be encapsulated in a kind of black box, and then you can understand it as a kind of a switching entity. And this fits also to the TSN concept, actually, as a switching entity with inputs, with outputs, and with some control functions and reporting mechanisms for the quality of service monitoring. And that is exactly also reflected in the structure what we have in the 5G network AAS. We don't talk in the 5G network AAS about SMF or about other AMF or network analyzing functions. This is not important for the usage. It's more important for the internal behavior of the 5G network, but not for the usage of it. And therefore, it's encapsulated.
Yeah, thank you, Joseph. Hopefully it answered the question.
Also, my email address is there. We can anytime discuss it.
Yeah. Okay, maybe last chance. If not, said there was already information from the 5G-ACIA office again that everything will be provided afterwards. Might take a few days, but all of this is recorded and you will get also the presentation. If there's no more question, yeah, I like to say thank you, especially to Bernd and Joseph for the well-prepared presentation. I know there's some work to be done to get there. So thanks again for this third webinar on the digital twins.
Maybe I just want to jump in because Krishna,
there's
just
one
more question.
question
Okay, then let's give for sure. We will take this.
If you don't run outside.
No, we still have time, so therefore it's fine. Please.
Bernd,
still in time.
Do you want to answer this or?
I first have to read it, to be honest. To scroll down.
I can read it loud, then you can think. Is there working?
No, there is no proof of concept until now. I think this would be a good task for one of those upcoming test beds that Uwe already mentioned to do this implemented. No?
Yeah, exactly. It says at the moment it's a concept, it's a paper, but we can find some partners to do this kind of test in one of the 5G-ACIA endorsed testbed. You know, we have many already. But the second part of the question is also if we want to analyze some spectrum analysis, then we need to go beyond black box model of 5G. I'm not fully sure whether I fully understand this part. For sure, spectrum is always an issue, and if you think about how many spectrum is required or used by a certain logical functions or physical function or by a link, this has for sure to be considered in the planning or in the setup phase of a factory network. Whatever you have as a spectrum, it will never be enough. And therefore, you have to carefully plan this ahead of time, how the cell, how the layout of the factory network, the radio part looks like. And I guess this is also a very important part for the engineering. And this engineering or later on update of the factory planning because you want to change something, then you want to know is the change fits the change to the existing deployment or not. And exactly for this, you need to have measurement data. Data from the history to know exactly if you change something, what does it mean for the 5G network performance. And this is also part of the network exposure interface definition. That means which type of information. And on the other side, part of the 5G network AAS, how to describe this in a unified way so that all tools, also the network planning tool, can have a benefit from it.
Thank you, Joseph, for the very detailed answer, and also Bernd for sure. Yeah, I said again, big thank and applause to you. Unfortunately, the others can't, so I will do on behalf. And with this, I would close this webinar, but making a hint to the next one, which is in more than 1 month. So in August, we currently make a pause here and go again on September 13th, same time. But as I said, everything will be recorded. So also for the other regions, they can still listen to it, and we experienced this already. This one is 5G services operated by industrial applications, so also a very practical one on the service and application area. And here we get insights from also two colleagues from 5G-ACIA, from Kurt Essigmann from Ericsson, and Joachim Walewski from Siemens. So already invitation to everybody to you can already apply for this on our website for the next webinar, September 13th. So thank you very much for joining. And with this, a big thank you, and we close the webinar.
Yeah, thanks Uwe and Jackie for guiding us through the session.
For the audience to listen.